Good evening and welcome to March's Power BI Manchester 2022. My name's Alex. So if you've not attended a session before, this evening we've got two fantastic speakers. We've got Augustin and we've got Johnny. Augustin is coming to us live remotely, and he'll be presenting first, followed by Johnny. I'll go through some slides and then we'll start Augustin off. So quick intro about myself. I'm a data recruiter, long in the tooth, been doing it for 18 years, and I run the Power BI Manchester user group alongside my colleagues, Ben, John Bayliss, who's not here, and also Sheb. I'm sure you've dealt with Sheb previously. He's done training events with. I run the Manchester unit for Rob Walters alongside Chris and Lawrence, and Dan is not here. And I said we're experienced data tech recruiters. So if you are looking for a new job, or if you are looking to hire somebody, or if you're looking for a career change or training, which Ben did last week, and we've got some training coming up next Friday, which I'll come to in a minute. Yeah, get in touch. So tonight, a little bit later than planned, but after my short intro, we'll have Augustin, and then Johnny will be on around 7, and then we'll have questions and pizzas and beers to finish off around about 7:45, and then we can probably stay until about 20 to 9 before the cleaners kick us out. So Augustin Dukoza Bukvich, he'll probably tell me off in a minute. Is that right, Augustin?
That's okay.
Oh, perfect. Okay, cool. Augustin is in my ear, by the way. He's an analytics architect, certified trainer, speaker, and Power Platform user group, and he runs the Stuttgart user group. He's currently a director at Thrasio, and I'll probably get to a bit of detail, but he's worked on various different Power BI projects and Power BI events, which we'll go into in a bit more detail. And then Johnny currently works for Watersons as a BI IT Power BI consultant, and they're based in the UK and Australia, and he's been working with Power BI and Microsoft Platform for the last 5 years, and he's been an attendee back in since his days. Was it Booking, or was it where you been working at? Travel Counsellors, that was it. Travel Counsellors, and then AO and a few other places. But yeah, he got his own YouTube channel, which she'll talk about shortly. And yeah, he's been at SQL Bits of the week, and yeah, he's fantastic. So he'll give you a bit more information about what he's up to and talk through his data information. And then, as I mentioned, we've got Power Apps training. We had Power BI last week. We had 40 attendees for Ben's session. We've got Power Apps with Dave Scally next Friday. So if you are interested in attending, we've had a few dropouts, so there might be a few spaces if you want to get in touch with me for the Power Apps training. That's a full day, so it's an app in a day. So you'll get training from Dave in the morning session, and in the afternoon, Dave will show you how to build an app. And then next month, we're back here again, the 28th of April, so 4 weeks today, 6 p.m. start, but please try arrive for 5:30 so you can get your drinks and everything else. And then we've got Pascal Kiefer, who Ben knows pretty well. He's done some work with him, part of the BI Samurai consultancy he runs. He'll be in person, and so will Steve Campbell. He works for Microsoft, and we're going through some fantastic. I'm getting their talk topics in the next few weeks, so I'll send them through in the group. And that's me done. So we will now pass over to Augustin. You're in Germany, Augustin, is that right?
Yeah, I'm based in Germany, Stuttgart. So
he's in Stuttgart. Okay.
Perfect. If everything is working, if you can see my screen, so welcome. Thanks to entire Manchester user group, entire team for inviting me and for having me here. So what I will be speaking today is about Power BI good, bad, and ugly. How to make your reports working and meaningful. So this presentation will not go deep dive technically, at least not in most of the parts, and will cover common mistakes that I saw and noticed throughout my project's career and everything, and that can be helpful later on for you. So I already got introduced, so I will not stay long on this slide. I'm Augustin, working as a Director Analytics CoE for Thrasio, which is US startup Amazon aggregator, but working with BI in general with data for last a lot of years. Every time I see this slide, I notice how long it has been. And working with Power BI since it was a small green icon before it turned yellow, all the way back to private preview version. Was working as a consultant for a few years and did most of the big Fortune 500 companies regarding Power BI and BI projects in general. Also, Power Platform user group leader, so if you want to join, take a look what's happening, join us on Meetup or LinkedIn or Twitter, whatever it is. So let's jump into this. So I divided this presentation into three major places where we find our problems with Power BI. Data preparation part, meaning Power Query, modeling part, and just the design part. Although we somehow put the design aside, it can cause also a lot of performance problems to us, but we'll come to that soon. So data preparation. So when you are starting preparing your data, you need to ask yourself a few questions. Who is going to use the dashboard? What are the key metrics and what audience really wants to derive out of it? And what level of detail is really required by the audience? I know probably all of your users, my users, will say we need everything, we need it yesterday, and so on. But based on the questions, we can do the following approach. We will find the data, we will connect to data. We will create different reports or dashboard for different audience sets and divide our information depending on who is using it, how is using it, and what's the general use case. Also, depending on the type of information you want to project, choose the right kind of visualization. If some information can be shown best by using a simple bar chart, why not use a bar chart? Don't overdo it, don't overthink it. Also, try to provide relevant information and try, even if it's POC, try to model your data for the start. And coming to our first part, to Power Query. So, as I said, everybody always wants everything, so including all of the columns available in the data from a database layer. Does it make sense? Usually not. So it's like when you're taking a child to a toy store. Normally, when you would ask your kid in a toy store what would you like to have, it's everything. But then you started to explain that you will buy just one thing now and the next thing when he behaves good or something else. Behave the same with your data. So give the users what they need now and rather prove it in the future and add more data than include everything. Because I saw this picture or things like this, something like this, a million times. So it's really imperative to only include tables and columns that are necessary to support your business needs. Any columns that are not absolutely necessary should be removed, because first they take your memory, increase the complexity, and potentially increase, not potentially, but securely increase data volume and decrease your performance. So it's not about minimizing the horizontal space, meaning your columns, but also minimizing your vertical space, number of rows you're including. If you don't need to take less 10 years, don't take it. So fact tables where columns have been removed or reaggregated, we can also remove the rows. So the smaller your model is, of course, according to needs, the better will be in performance. And one common mistake I see when we're talking about this is having all unique IDs in a fact table. This is super fine in the database layer, but it should not be included in a data model unless it really serves a concrete purpose. So usually it takes a huge amount of space because there are unique columns. And if you're having a fact table of 200, 300, 400 million rows, you will really feel all those columns. So if you have data that you don't need to load, simple decision is don't load. Loading data that you you don't need will make your Power BI reports way bigger and slower than they should be. And we're all living in a good old Excel world, where we all used to just call our IT department, ask, give us everything, because it was simply too hard to go back to them and adding some missing columns, because it was a long process. Currently, self-service, most of the companies can do it, so think about that when you're developing your. Then we're coming to, when we decided what should we include, what we need, what we don't need, coming to our Power Query, our data mashup engine. Sorry. So when we're talking about Power Query, there are some concepts that should be remembered when we are preparing it. So where should we do our data shaping? So for some data sources, like Excel files, there is no option to transform data on the source side. Therefore, Power Query is an obvious choice for this. And for each and every basically non-database data source. But if you can, like Matthew Roche is always saying his most famous words, push transformation further away that you possibly can. So if you can do it on your database layer, do it on your database layer. If you need to do it in Power Query, and if you are doing it in Power Query for any purpose, keep in mind you can do pretty much everything. So whatever is possible, you can do it even if you don't know a single line of M code. So there are currently, I think, 200 something ways to shape your data just through user interface. If you know a little bit of M, possibilities are endless. But we need to be careful there. Single thing which is called query folding. If you know it, great. If you don't know it, just basically it's when we do a transformation, it's in Power Query, it's a question, can our Power Query transformation be translated to a single SQL statement? So some of them can be, some of them can't. So for some data sources, such as relational databases, but also some non-relational data sources like OData, Active Directory, or Exchange, Mashup Engine is able to translate your M code or whatever you are producing through user interface to a language that the underlying data source will understand. In 99% of cases is a simple SQL statement. Some transformations can be translated, some not. So for whatever you can find when you are thinking, if you know TSQL from earlier, whatever you can find the same statement in SQL, it will be translated usually. So removing columns, renaming, filtering rows, grouping, merging, appending, all those things will be used. On the other hand, some things will prevent your query from folding. So merging queries, for example, based on different data sources. Appending queries or unioning based on also different data sources. Creating index columns, because we are creating them on Power Query, also will not fold. Also changing a column data type. So be aware what query folding is supporting and whatnot when you are using it. So that way you can push all those steps which are not folding to the end of your statement list. So you can at least fold most of your queries and leave to the end what cannot be folded. Because once you break the query folding, it will not start again. Keep in mind the steps, the order of the steps and thinking of query folding, because it will really help speed up your refresh time. And it will put power on a backend engine. Also, don't be fooled. In some cases, so for this presentation, I didn't prepare Power Query demo because it's a complete separate session I have. But if you ever work with it, if you know where query folding is and what is it, there is a button in Power Query View Native Query. Usually, if it's enabled, meaning query is folding. If it's grayed out, query is not folding. That's correct in most of the cases. Some data sources in a backend, like for example, Snowflake, it's grayed out by default simply because connector is not supporting it, but still query is folding. So there are a few ways how to check it. So if you need logic, you can find it on my LinkedIn, or I can paste a simple command later on in the chat. But you can always check, is your query folding with the 2 simple lines of M code, and be aware that it's folding. Then, regarding preparation, I think one of the most important decisions you can make. So when you connect into a transactional database with a direct query, a good example is, I think it was from Michael Kowalski from Microsoft. It's like being in a busy restaurant and just saying to all of your customers that their food is in the kitchen, and they can go there and talk with the chef, whatever, and take whatever they want to. What it will do, it will actually slow down everybody. Cooks in the kitchen, waiters, because they have no idea who is looking for what. Everybody will milling around the kitchen and trying to find where, I don't know, their main dishes or their starter is. And kitchen staff who is really trying to prepare the food will have to fight for their physical space, and it will be a complete mess. Same thing is with our direct query. If we are using our transactional database for a lot of different things, and then we are starting querying it with a bunch of reports, it need to be slow. So, first question, is your direct query model optimized for that? From my experience, I can say usually 90% of those, when you start doing it, is not optimized. So even when it is optimized, it's up to 5 to 6 times slower, and up to 100 times slower when it's not optimized, when you just connect to it without without proper indexing, without everything. So if you can avoid direct query, choose import, pretty much always go with the import. Of course, there are cases when data will be simply too large to load. Then you can do composite models. You can do hybrid tables enabled now. So you can do a lot of things. It's relying just on the direct query. It's really not a good thing to do. So if you really need it, there is no other way around. But if you can avoid it, try to do it. So only way when you need to do it is that your database or data you are fetching is so huge that you cannot fit it simply in Power BI. Or you need data in real time. But even with the real time, it's a question what real time is. And if you need a real time, you can always go with hybrid tables with a lot of options to avoid only direct query. Also, some DAX functionality limitations like time intelligence, calculated tables. So whenever you can avoid it, try to do it. Then we are coming to modeling part. So should we use our star schema or not? When we are talking about models at very high levels, we think of flat model, simple master detail tables, and a proper dimensional model. And for POCs, for example, I see a lot of people starting with, okay, give me that Excel, I will load it as a flat table, I'll do some quick reporting. Let's say it's fine. But later on, if POC went well, we did it in half an hour, people started using it, adding more and more data, And then after 3 months, I don't know, when they are using it, they imported a bunch of things inside. And you need to create a proper star schema. It will be a pain. So rather start immediately, no matter how small the data source is I don't know, 2,000 rows from Excel. Try to divide it into star schema. So in this example, it's visible. So I have some dates, I have some customers, I have some products, and I have my fact table, where I have my quantity, unit cost, unit price. So do it immediately. By organizing the information into fact and dimension, we store as little data as possible while maintaining really a consistency and integrity. And we will have much more performant Power BI report from the beginning. Shall I use Snowflake? So I'm not saying the star schema is the only thing it will work. So Snowflake will work perfectly fine. There are some trade-offs you will need to accept and you cannot avoid. But what I'm trying to point out here is 2 key things you should know. In general, best practice within each and every tabular model is to use star schema and try to avoid Snowflake. Using Snowflake will only create more complex, more relationships, and query will need to traverse through more relationship, adding additional foreign keys or primary keys, which doesn't actually add any value and simply taking up additional memory. So we always try to put our model as simple as possible, and star schema is a perfect way to do it. So in this simple example on the picture here, so if you have product category and product, why not just merge it in a single dimension table? So I know simplifying things, and it's not gonna make it each and every time. Whenever you can do it, do it. Then coming to DAX. So we decided what data do we need. We discussed with our users. We know what kind of report we need to make. We did Power Query transformations. Our query is folding. We created a super nice model. It's a star schema. And now we need to create some measures or some calculated columns or whatever. So what I try to point out here, I will not go into DAX on, I don't know, Italian's level. Trying to point out here what things you should avoid. First thing is search. So the search function is expensive as hell, as it really scans each and every row for a given value. So if you can avoid it, so the better solution is to create even a new column in your model and then do it over that column, then using a search in a measure. So when you use it in a measure, it has to perform search operation on the fly. If you have 1,000 rows, you will not probably notice it. But if you have 300 million rows, your measure with the search function will be extremely slow. So whenever you can create a new calculated column, and if you cannot, you can try to find. Because find is usually up to 5 to 10% faster than search in simple reason, just because it's case sensitive. Also, we have in DAX contain string and contain string exact, which are providing same features as search. Contain string is providing same feature as search, and contain string exact same feature as find. So there are few options, but try to avoid search with any of those options is better than using a search specially in a measure. The next thing we should avoid whenever possible is our if error. if error is function that seems rather okay for whoever is coming from Excel. But using it in DAX will cause a real performance degradation. So there are simple ways to avoid it, and people are usually using it when they're coming from Excel. They need to somehow handle errors, and usually it's in division. So in DAX, we have a simple solution for that. So use divide, it will handle errors for you, and you don't need if error, because you will pay penalty for every error raised when you are using if error. And last but not least, on avoid whenever possible, is contains function. When they are creating, so contains is usually used in virtual relationships. So whenever you are using it, you need to remember that it's extremely inefficient and really causes your performance to go significantly down. The next best option is to use intersect. First, it's a bit easier to write, pretty much do the same things, but it's a bit more optimized. So it will give you the exact same result, but a little bit faster than contains. But when you are utilizing your virtual relationships, what you should use by default is treat_as. Only thing which you should remember, but if you were using contains and intersect, treat_as requires a little bit of adjustment of simply thinking, because doing things slightly different. And what you need to be aware of is that it requires compatibility level 1400. So at least if we are talking about on-premise, at least SQL Server 2017 or higher. If you have some really old on-prem analysis services, treat_as is not an option for you, unfortunately. Then the filter syntax. So filter is a function that it's super highly used, so everybody is using filter. Everybody needs to filter something, we use it daily, but it's most, I think, misunderstood and wrongly used function in DAX. We are filtering tables, columns, values, keep filter, so lots of options how we can do our filtering. And for that, let's switch shortly to Power BI. So I have my simple data model. As you can see, it's not just the two tables, nothing special. One table is almost 10 million rows. The other is 12.6 million rows. So it's not too big. Have simple years, so few years. If you look at it, we have 3 years. We have a bunch of products and counting number of orders. And when we are creating something like this, questions comes to pop up. So for whoever we are creating it, okay, what's my orders for product number 1, 2, 3, 5, whatever it is. Then what we usually do is start with something like this. So I need to calculate for my product 1. So I'm doing just a basic calculate with taking my total orders and putting online sales filtered by product key equals 1. And by doing that, I will get my result, which is returning me exactly what I was asking for. Doing all the products which are number 1, and for each and every product giving me the total orders of product number 1. First question arises when the people are new to DAX, this is wrong, this is not what I need, or something like that, and they are using a basic DAX function. What that DAX function is actually doing, so this one, is nothing else than internally doing this. So it translates internally to this. So it's taking my total orders, filtering my product key column, removing all the filters from it, and then putting a product key equals 1. So first removing entire context from my product key column, and then adding a key one. Meaning, in this case, it's really returning me a result what I asked for. Because here I removed all the context from my column and just added single line here, doing exactly what I was asking for. Then people are starting to play and coming with something like this. So, problem with this, I saw this a million times, especially when people are starting to use DAX, creating their first measures. This function will work. So if I put this in, it will give me exactly what I asked for. So this is what it will give me back. And it's working perfectly fine if I have a smaller number of rows. Major problem here is this part. I put a filter on entire table and just asking for a product key, meaning I need to load up entire table. In this case, I have no idea how many columns does it have. And searching for a single column. So never, ever try to filter entire table when you need to filter a single column. Always filter a column. So even though you will get exactly what you are searching for, try to avoid it because it will cause you performance issues. Then the next best option is using values. So with values, you will get something like this. So you are again calculating your total orders, but filtering on your values. What values does, in this case, actually just taking you a distinct values from your product key column and filtering on that, meaning it will be much faster because it will usually, if you are not filtering a unique key ID on a huge dimension, it will be much smaller data set we are filtering over than without values when we are just pulling in the column. So that's the next best option, and by doing that, we'll again get our results, but much faster comparing to this option. And then the last thing we can do is actually use our keep filters. Few reasons why. First, it's more optimized than values. Second, just a single line of DAX code less, so you'll be a bit faster if you're writing 200 of these measures and hoping you're doing it with Tabular 8 or not through Power BI Desktop. So keep filters is, out of these, the best option regarding performance and readability of your code. So by putting this all together, I just wanted to show you the simple filtering exercise in Power BI can result in, I don't know, 4 or 5 different options how to filter your data. Each and every of those having its pros and cons. And by understanding it, but knowing what you are doing and what you're trying to accomplish, try to optimize your filter statements as much as you can, because it will really cost you a lot if you are not doing it. So going back, this I just On this slide, whatever I showed in Power BI is here, so try to avoid filtering entire tables in here. And with that, since we're just explaining filtering and what's behind it, let's assume we did our modeling, we did our docs preparation, and we are moving our design. Although design is, you can look at the design from multiple perspectives. One of the things is design is not just it's not just for visual appealing. It's nice to look and comprehensive immediately and everything. It can really cause you performance issues if you are not designing it well. But before we jump into that, when we are talking about design, first we talk about choice of our charts. So be aware that our brain is really vision oriented. So most of the humans are relied on vision. And our immediate recall, meaning 30 to 40 seconds after something is shown or said, we recall for picture 98% of things and speak just 90. So talking about 2 minutes. Meaning 2 minutes from now, you will remember this picture pretty clear what I showed you, but you will probably forget at least 10% of things I was talking about. After 3 days, you will still remember probably this part of the picture, not the text here, but you will completely forget what I was talking about, and probably nobody in the room will be able to do the exact sentences I was talking about. Having that in mind, that's why our choice of charts is really important. First thing, when we are talking about choice of charts, the one you should avoid always, and I would put idea on ideas.powerbi.com to simply remove it from Power BI, is a pie chart. So I don't know what to say about pie charts, just don't use it, because if you have more than 2 values or 3 attributes you're trying to show on a pie chart, it will be completely unreadable, and it will take you a lot of your screen real estate without providing a lot of value. Also, cards in Power BI. They are great. So I am using them daily. Everybody is using them. But try to provide a context. So card itself is not providing any context but a pure fact. So here we have a sales of 3 million. We have 20,000 volume and things like that. But I have no idea what is happening, actually. I just have a statement. If you do the same thing with a card and provide some coloring, some comparison to previous year, on the same amount of screen real estate, which is really precious because you have just a single page or multiple pages, but each and every page is fixed if you're not expanding it for an endless scroll down. Try to provide as much context as you can. That way, you will give a much more information, and it's immediately visible what I'm trying to show and what I'm trying to tell. Then we are coming to, when we decided what charts, we start to think about performance. First, try again, like same as fetching the data, try to avoid charts where show me everything over everything. So show me all the products with total orders for entire period over whatever. So try to avoid it. So either use, so this kind of chart, first is unreadable. Second, I remember in one of the projects I was working, we had a chart something like this, and it was actually fetching over 100 million rows in a query, just to calculate what needs to be displayed for a chart. Also, data loads into memory and is uncompressed at each and every refresh. So processing creates huge demands for memory. Try to use top-end filters. So top 5 products, bottom 5. At least put it to be readable, and then we can expand it, go into more details with drill throughs and so on and so on. Next thing regarding performance is our slicers. So everybody loves slicers. We all love slicers, but slicers are a great way of allowing users to navigate data, but come at really performance cost. So each slicer is generating 2 queries to your data model. One fetches the data, and the one is fetching selection details. Adding too many slicers will drastically reduce performance of your page, especially if you're having, I don't know, 100,000 products and you put a product slicer visible always, people are scrolling through it. So try to remove unnecessary slicer and use a filter pane. So there is a filter pane. I know it's not the best looking, but use it whenever you think you can save on performance, because your user will be much happier having a super fast report than having a nice slicer with a slow report. Also, number of visuals. So using too many visuals on a single page will slow your performance significantly. Limit the number of visuals, widgets, so number of elements on a page. Each and every thing on a page is an element and sending some kind of query, at least a rendering query into the backend. So even those lines, shapes that you are putting in, push them to background, create a background in PowerPoint, in Adobe tools. And if you really need all those information, create a drill through pages, create a report page tooltips. They are a great way to provide additional details without jamming more and more visuals on a single page. And having said that, I think my time is over, so I would like to hear if there are any questions and invite you to reach out to connect. If you have any questions offline, you can simply reach. So I want to thank you all and thank the entire team of Manchester User Group.
Okay, Augustin, can you hear me?
Yeah.
Yeah, brilliant. So thank you very much from everyone here. I haven't checked what's online. We've got a few reactions coming in. I'm going to let you check the questions in the chat, but from our perspective here, does anybody have any questions that they'd like to ask, or comments, thoughts?
Mention about direct query and it's quite slow. So is that on a relational table or on an analytical model, such as analysis services?
Okay, so the question was, Augustin, we mentioned about direct query and the fact that it's quite slow. Is that generally towards a relational model or directly to analysis services, so tabular model?
Yeah. So depending on what we are talking about, if you are talking about direct query to a relational database, it will be, as I said, even if it's super optimized, 5 to 6 times slower than import mode. When we are talking about live connection to on-premises analysis database, it will still be a bit slower simply because of network latency comparing to import mode. And the third thing we can compare is actually composite model, where you have Power BI data model, fetching it from another data model and enriching it with additional tables. Although it's already Power BI data model, it's published on service, it will be in a composite part a bit slower than the original model. Even if you add just, I don't know, 10 additional rows, simply because it needs to fetch it from the other model. Hope that answers the question.
I think so, yeah. Anything else for anybody?
Just a comment of the analogies, toy shop, restaurant.
Okay, good. I should hand this kind of mic around, but I love the comment on the analogies of toy shop and restaurant and stuff like that, because obviously we're all food oriented here with the Ivy restaurant next door. Anything else from anybody? Yeah, go on.
What would you consider most important? The presentation, which is
Okay, so what do you consider more important? The speed of the presentation, i.e., I guess the data refresh when you click on a report, or the quality of the data? Or the quality of the presentation, so it's easy to understand. So do you have something that looks crap but is really fast, or, excuse my language, or it looks really snazzy and wows everybody, but perhaps is a little slower? If I can paraphrase.
I can tell you from my position, so working as head of Analytics Center of Excellence, both options are bad. So if you have correct data but a shitty looking report, then users are complaining that they don't get it, they don't see the information immediately, and so on and so on. If you have a super nice report with a bad data, they will notice it anyway. So you will have complaints both sides. So try to make a nice report with the correct data.
So here's one of the answers from a consultant where it depends is not the right answer. Yeah. The answer is you can't have either. It's got to look good, and it's got to be fast, and of course it's got to present absolutely the right data. Okay.
I would always go for a fast and correct. So looks good. We can add later, but if it's correct and if it's fast, we are halfway there.
Yeah. Cool. All right, I think let's wrap that one up. Thank you very much. I'm going to shout for Alex, see if he wants to talk to us before we hand over to Johnny. Doesn't look like he does. Augustin, thank you very much, mate. Enjoy your evening. Enjoy Germany.
You enjoy the beer afterwards, and hopefully I'll join sometimes live there.